Hello, Sarah. Okay, let's see.
Helena, hello Maria, hello Sarah, hello Niley. We got the whole gang here today.
Yeah, let's wait for a few more. We had quite a few
No
sign
rush.
up.
No rush at all.
So we'll just wait. And people tend to arrive between on time and 5 minutes late, which is fine.
No worries.
Okay. Okay. There we go.
Maria gets the award for the best background.
Thank you. It's my Swedish heritage, and I thought I'd cheer myself up, but we're stuck in the house here in London,
I hear you.
Fair enough.
What do they call it in Sweden when you have snack time and have a little talking cake together?
Oh, fika.
That's the best thing about Sweden ever, in my opinion.
I know. Oh, you might like this one then. Wait a second.
I miss
At
it.
what time is it?
I miss Filka. It's 11 a.m.
So fika is a word.
There's a book about it, actually.
Yeah, fika is a word where you basically meet your friends, have a cup of coffee, have a few cookies as well. And if you ring the office, someone's office around 10, you go, and 3 o'clock in the afternoon, you never get hold of anyone because the whole office have fika together.
Yeah.
Oh, that's nice.
Yeah.
In France, they have something, it's called GOTO, and it's at 4 p.m. Right, Sarah?
Right, yeah.
I remember that from when I was a kid.
Favorite time of day, yeah.
Indeed. Oh, it's nice seeing so many people. So to all the other attendees, you may turn on your video if you'd like. We love seeing faces.
And backgrounds.
Oh, and backgrounds. I think I'm like the only person who can't have a background. It doesn't work on my computer. I don't know why.
Maybe when you update the Zoom, that's when it started working for me.
I did. I updated it already.
Oh,
So yeah. I've got such beautiful pictures of the beach in the background and everything, and I can't use it.
You have to buy a green screen.
Yeah.
In the background. Then you can do it.
Okay, I'll put my green pillowcase in the background or something.
Yeah, as long as that'll work. A green sheet or something will work.
Yeah. It will work.
Yeah. At least it needs to be the green that the Queen was wearing in her ensemble. People keep using that as a green screen and projecting all sorts of stuff on her clothes.
Yeah, this one. Right, there you go.
Oh, yeah, there we go. Nile also has a cute one with Star Wars Lego man.
That's my son's birthday theme. So we're doing a Zoom. So I have all sorts of Star Wars Lego.
Oh, are you doing a Zoom birthday?
Yeah.
Yeah, when is it?
It's Sunday. Yeah, we're
Sunday.
Celebrating on Sunday. Yeah. 5
5
years old. Yeah.
Oh, poor. I think for kids that must suck.
No, we're spoiling him though, so he'll be fine.
Yeah. Yeah, my cousin just turned 32, I think, on the 14th. Yeah. And we also had like the whole family met on Zoom, and as you know, Nile, my family is Brazilian, right? Yeah. So everyone's screaming at the same time, and even though I'm the one who loves talking, I was sitting there just listening.
You can mute.
Get a word in.
You can just mute everyone.
Yeah.
So that's a good thing. All right.
Oh, funny. All right.
I think we're good here.
I think we're good. I'll keep bringing up the attendees to panelists. So, oh, there we go. One more. Wonderful. Hello, Joanna. So, Jim, shall we start?
Oh, yeah, it's a great idea.
Okay, so I'll just say hi, everyone. Thank you so much for joining. I'm very, very happy Jim is finally here because I've never met him, even though he was signed up twice to our conference in Berlin, hey? And then always something happened.
I try to bring in good replacements, but I'm sorry for that.
Yeah, but you know, we missed you.
In person.
We are very much looking forward to having you as well. Jim is also giving a masterclass. I will post the link in the chat. So have a look, sign up for, oh, okay, this doesn't work, for Jim's masterclass. Obviously, it's a virtual masterclass, so wherever you are, you can join. Okay, so we're doing this GOTO night with Trifork and GOTO Academy. So Kalina, thank you very much. And yeah, I'll hand the word to you.
All right. Well, Miguel, Niley, Sarah, Maria, Kalina, thank you all, and everyone else, thanks for being here. We're going to talk about passwords today, and we want to talk about passwords from a developer point of view around how to build an authentication system and deal with passwords. And the thing is, why are we talking about passwords? It's like we've known about this for decades. This is because a lot of things have changed around how to set a good password policy and how to store a password in your database for your users in just the last couple of years. So this is normally a many-hour presentation. I've got the real essential bits that we have to get right as developers, and to give you some good information around building an authentication system or upgrading your current authentication system that might not handle some of these problems that we're going to discuss today. So let's get to work here. Who the heck am I? My name is Jim Manico. I'm going to be your presenter today. I'm the owner and founder of Manicode. We're all a bunch of teachers. We teach developers to write secure code. And I've been doing this for a long time. I've been coding for a long time, and I'm just real grateful. I love what I do for a living. Teaching is a big part of my family. I'm the 4th generation educator in my family. Please don't hack without written permission, and please don't use open source software unless you vet it first and keep it up to date. The moment you use a third-party library, you have a responsibility to keep it up to date because security bugs arrive in these libraries on an increasing basis. So where are we going? We're going to talk about modern password policy. We're going to talk about the importance of password storage. We're going to take a look at hashing primarily. We're also going to take a look at some adaptive algorithms. And let's get to it. Let's start with this. Look, this is called a security oracle. That's what this is. Again, this is called a security oracle. I mean, I'm going to swap. There we go. We want to be here. There we go. What's a security oracle? I'm not talking about Oracle, the database. I'm talking about Oracle like the informant, like some error message that gives the attacker more information than they need. This is a real bad one, right? So this is leaking just by attempting to log in if some other user is using that password. Another common security oracle around passwords is when you try to log in and the error message says, oh, that user does not exist, or the password's invalid. And by saying the password's invalid, you're also saying that the username exists. And this will let me as an attacker enumerate valid users in your system. So just getting warmed up here, let's really get to the meat of what we want to talk to today. We want to talk about password policy. Here's the first rule of a good password policy is you don't want to limit the strength of a password that the user can pick. Now what that means is any printable character should be okay for a password character. If you're limiting passwords because you want to stop certain dangerous characters, like if you want to stop SQL injection, you may want to stop the double quote or the single quote character in validation. And if that's how you're doing passwords, it's doomed to failure. You don't stop SQL injection by limiting characters. You stop SQL injection by doing query parameterization. Also make sure that your passwords are not unlimited in length. You have to limit the length of a password. It should be a big limit, at least 64 characters as a max password. But if you allow unlimited password size, that becomes denial of service. And what that means is, let me explain this. Back in the day, there was the Python Django project, a big framework, really good one too. And they had a good password storage algorithm that was slow on purpose to delay the attackers. And so, but they didn't have a password size. It was unlimited. So back in the day, I could log into Django with like a 10 megabyte password and take the whole server down, and shut it down, denial of service. So this is really the first really big principle, is your system should take any character for a password and still be secure. And so what we want to do now is look at modern standards. So I want you to consider this. I want you to consider the standard from NIST. NIST is the National Institute of Standards in the US, and we have a brand new document, the Digital Media Authentication, from like just a year or so ago, that really changes what password policy should be. And if you're thinking, but I am a European, why do I care about US standards, you filthy American? I'm a European, and that's okay. I'm not saying you have to use a US standard. I'm saying that Jim Fenton and the team at the US standard body, the work that they did is exceptional, and everyone who cares about security should read it to get good information from it. I read European standards, GDPR. I like the authentication guidelines for banking are really good. So we want to read whatever we can, pull the goodness out of it, and use that within our software, right? And by the way, if your software has really sensitive data in it, doing financial processing, or is a high level of risk, excuse me, a little Corona cough for you. Excuse me, pardon me for a sec. If you're doing passwords only for a serious system, you should be using multi-factor. In fact, what I like to tell folks, just to get them going, is if you have a serious security system and you're just doing passwords for security, that's negligence. We should be doing multi-factor 10 years ago as a basic security control. So if you don't offer your users multi-factor in some way, I think that's negligence in your software. Really consider that quickly. Also, we want our users to use a password manager, but you can't just say, here's a password manager, go use it. They're complex, especially for non-technical users. So if you're gonna force people to use a password manager, make sure they go through training how to use it. It's not as trivial as it may seem. And so one of the biggest attack types that's new in the world of passwords is this idea of credential stuffing. Now, what is credential stuffing? This is not something that goes with your turkey for dinner. This is a whole different issue. Credential stuffing is when attackers find a username and password that's been breached in a public database. Like, for example, this old system called RockU, a media server, was breached years ago, and the entire username password database for RockU was published to Pastebin. The same thing happened to LinkedIn, Oath, and MySpace, and many, many other companies. All these breaches where password username data was stolen are in these big hacker databases or security databases now. And what attackers do is the problem is users will use the same password in multiple systems. So if I see a username password in one database that's been breached, I might try it in a different system to see if the user is reusing that password for their username. And that's called credential stuffing. It's a big problem, especially in the world of VPNs and similar. So multi-factor will really, this again, multi-factor or negligence. You got to use multi-factor. It will shut this down pretty well. Also, consider not using an email address for a username. That's public data. Also, and most of these stuffing attacks are done via bots. There are many of commercial services that provide bot detection for your web application. It's worth considering. Also, so that's the live defense is whenever someone tries to register a new username password, or when someone tries to reset their password, we should check if that combination exists in a public database, and if it does, block the user from using it. Here's the other piece of stuffing, of credential stuffing. If for some reason a big breach happens, like from Gmail or anywhere in the world, there's a significant breach, that leaks the username passwords of those users to the world, then what that means is that can lead to let me try this again. There's a major breach. Let's say Gmail, the username passwords of Gmail get leaked to the world. Attackers will immediately use those credentials, the password username combination, to try to breach other systems. So when you see the big breach, get that database as quickly as you can and invalidate all users affected. You can do a username password match or just a username match. Some of my customers, when they see a big breach and they see username and passwords leaked, they just go through all those usernames, lock it, and force password reset on the affected users. There's not an easy way to buy your way into this. You got to build a lot of this. But this is how you deal with this relatively new category of credential stuffing, and your password policy is not going to help solve this problem. So here we go. Special publication NIST Special Publication 800-63b, the Digital Media Authentication Guidelines for the US and US companies. Please, still valid to look at this. Remember, rule 1 is don't limit the characters of a password. Rule number 1. Rule number 2, allow at least 8 characters as the minimum password size, and up to 64 characters as your minimum max password value. So I should be able to, if I have a 64 character password, it should work in any system. And even bigger is better. You can go a couple hundred as a max for passwords as well. No harm. 64 should be the minimum for the max size of passwords. Also, if you're not doing multi-factor, then I recommend 16 characters or more for the password. Actually, several large US companies are already doing this because they have trouble rolling out multi-factor. And 8 characters, that's pretty small in my opinion. That's the mathematical minimum, but I really recommend that you do more 10 characters as your minimum, if not 12. In fact, the OWASP Application Security Verification Standard, they suggest 12 characters as your minimum password length. Mathematically, the larger your password size, the strength of that password increases. Next, you don't want to have context-specific passwords in a password. Like if we were doing a system for GOTO, the GOTO conference series, we would never want to see the word GOTO in a password ever. So the word password's a context password because it's a password field. So usually they recommend 10 to 15 words contextual to your business and brand should never be allowed inside of a password or similar. Also, check against the list of common passwords. Let's look this up for a second. Let's go check this out. So I'm going to go to Daniel Miessler's list over on GitHub. So check this out. I'm going to dig with you here. We're going to go to GitHub, this great repo called SecList. And if I go dig into Daniel Miessler's SecList list, I can look at where is it? Passwords. There we go. We got passwords. We got common credentials. Boom! There's the top passwords in the world being used today. And the thing is, I would take the big
guys,
list. I would.
Can you see the screen?
Can you see the screen? No.
I don't see the GitHub.
Is it there?
There we go. Nice.
Oh, I see. I'm sharing out. Okay, there we go. Let me walk through this one more time. What did I just do here? So there we go. Thank you for that. We go to Daniel Miessler sec lists. Then I'm going to go down to passwords. Then I'm going down to common credentials, and boom, we have the top passwords in the world used in the world today. What I suggest you do is figure out your algorithm for password policy, loop through this list, and pick the top 50 to 150,000 passwords that would typically fit your policy, but is abnormally common, and don't let users use it. Because this is exactly how attackers go after you with brute force. They figure out your policy, build a list, and go after you with that list. And this list should change on a regular basis. And this is, again, one of the recommendations from NIST of how to handle how attackers are actually going after your software. All right, so where else are we here? So I'm gonna switch here. Actually, I want you to see this. There you go. There we go. So check against the common passwords. We just covered that, right? So go to SecList or similar. Block the top 50 to 150,000 passwords that would normally work on your system. Great. Next, check against the list of breached username password pairs. That's credential stuffing. Troy Hunt has a service to help you with this as an enterprise developer. Next, you got to handle brute force in some way. If an attacker knows a username and is trying many attempts against an account, we have to detect, throttle, or block that attack in some way. This is hard to do in code. It's usually a second service you're using to help you with that. Next, all these special character rules, uppercase, lowercase, number, special character, get rid of them. They don't help. They don't really help mathematically in terms of having a good password policy, because attackers go after you with these methods we just talked about. Also, security questions and security hints, they don't work. They can look them up in social media or guess them pretty easily. So we recommend, again, security questionnaire hints. And last, password expiration is not useful because we see users building a pattern every time they're forced to reset their password. So only do a forced mandatory password expiration if there's a reason, like you were breached or there's a major technology change. But this idea of password reset every 3 months, it doesn't help security at all. And last, we want to allow any printable character, again, like we started with, even emoji, anything Unicode, anything but a control character, even spaces should be valid for a password as well. And this changes the game of password policy. This is a radical departure from the uppercase, lowercase, number, special character that many of us are accustomed to in enterprise programming. Here are some suggestions from Dr. de Rick. This is a Dr. Philippe de Rick out of Belgium. He's got a PhD in web security and is a real active intellect in the world of OAuth and similar. Big fan. He suggests 3 more things. Number 1, have a password strength meter to inform the user in real time if they're building a good password. Number 2, make sure that your password system is compatible with the password manager. So like a paste operation shouldn't be blocked or similar. And also, and this is built into the operating system these days, but if someone's trying to log in via mobile device, let them see the password as they're typing it, because mobile typing is not as accurate as a normal keyboard. So, okay, things to think about. So what else? Where else are we going here? So that's the new, by the way, why should this password not work in your system? I can think of a couple of reasons, right? It's got the word password in it. That's a context word to the password field. It's only 10 characters. I prefer 12. And it's the 30,000th most common password in the world today as well. It's a very common password, less than the 50,000 minimum mark. So there's no way any system should ever accept this password. And go change your password. Try this. If it works, bad password system. I state with respect. So that's some of the new information about password policy. Let's now talk about password storage. A user has registered for your system. They've given you a password that's very important, and now you have to protect it. First of all, these days, I really don't want to build this myself. I'd rather use an identity provider, OpenID Connect, which is like Google login or LinkedIn login or Twitter login. I'd rather do anything than build it myself. And again, the real trend is to use an identity provider like Ping or Okta or Auth0. For big companies, I'd go that route. But if you have legacy software or you insist on building it yourself, this is tough to get right. There was a study recently that had 43 senior freelance developers build a registration system for users, and 26 of those senior developers left the password as plain text on their first release. This is an epic problem. So we gotta ask the question, when does how you store a password really matter? And this is really about offline attacks, like when the attacker has stolen your database with SQL injection or stole the backup or some admin problem, and now your database has been stolen. That password and username is now in the public. And so why does, what's going on here? Do you trust apps like Keeper Security to create new passwords and store them? I don't know much about Keeper Security. What I care about, more important, Niley, is what algorithm you're using. So I'll show you how Keeper should store a password. Now, if Keeper is a password manager, then that should encrypt and decrypt the password. If you're storing a user password, not for a password manager, but for authentication, then we shouldn't use encryption at all. So the point is, again, if I'm storing a password in a password manager, I want to use really good encryption so I can see the password. But you should never be able to even see your user's passwords. You should have no idea what your user's passwords is, and we want to store them in a one-way fashion. I'm not sure about Keeper and how good their encryption is, but I can show you the common algorithms used for storing a password. So when a user logs in, we can verify that that password's correct without ever leaking the password to the technicians using that system. So this is the goal here. So again, password storage matters when someone has stolen your password database. The attacker will take that ciphertext and analyzing it with supercomputing ability. Like an attacker can build a GPU rig like this to do trillions of hash attempts per second. And these breaches have happened very frequently. So this password data is out there. So again, let me take a step back. What's the point of this? If someone steals your database and is analyzing your password data offline with supercomputing capability, we still want to stop the attackers from getting to our password in any reasonable amount of time. That's the problem I'm describing here, Nali. And if you're doing password storage for a password manager, whole different problem. This is about authentication password storage. So let's dive into this. When you're storing a user's password for authentication, I recommend 3 steps. Pre-hash the password, and only 3 algorithms are good for authentication-based password storage. Only 3. The best is Argon 2i. The second best is Bcrypt, and next is Scrypt. These are the 3 adaptive storage algorithms made for password storage from the ground up. And again, these are one-way algorithms. When the user registers their account and gives us a password, we don't store the password, we store a one-way hash, a modern password hash of that password. So when we look at it as a technician, we have no idea what the password is. When the user tries to log in, we're not going to decrypt the password. We just use a password verify function to see if they match what we're storing. And this never leaks the password to the operator of the software. That's the goal here. So step 1, a user just registered. They give us a new password. We want to hash the password first. And this is not a good algorithm by itself. Now we're talking like SHA-512. That's a one-way hash. It's a message integrity code. And I can go Google a hash and figure out the answer. Look at this service, right? This service is the hash cracker in UK. I have an MD5 stored password. I put it into the service, and it just gives me the password. What's the point I'm trying to make here? If all you do is hash the password with like MD5 or SHA-1 or SHA-2 or Whirlpool, that's horrible, horrible password storage. If you're doing a salted hash, like MD5 plus a salt, that's still terrible password storage. So I'll come to the how to solve that in a second. But step 1 is I'm worried about performance and truncation of long passwords. Remember Django and Python? If you have a giant password that you feed into one of these storage algorithms, that's a performance problem. So if you hash the password, a big password, down to 512 bits and then protect it, it solves the performance problem. Also, one of our go-to algorithms is Bcrypt. Bcrypt truncates a password beyond 72 bytes, reducing its strength. So if you hash to 512 and then Bcrypt, you solve that problem. This is a complicated discussion. I could spend hours on this. So this article from 2016 is written by Dr. Devdatta from Dropbox. They published exactly how they store their password. It's really the answer to this question. I want you to read the article if you care about this topic. So step 1, pre-hash. Take the password, run it through a hashing algorithm like SHA-512. Now we got 512 bits hash representing your password. Step 2, use a good algorithm. Only 3 algorithms. Bcrypt, Scrypt, and Argon 2i. What Bcrypt does is it adds a time cost. So if I say, let's store the password with Bcrypt work factor 13, there's a several second delay in that login verification. So if I'm logging into your system, I'll see a couple second delay during login. But if the attacker steals the database, oh, they got a big performance hit. Like, look at this. With Bcrypt, if I'm using MD5 on my laptop, I can do about 200 million rounds a second. If I use SHA-1, I can do about 68 million rounds a second. And Bcrypt, only 390. The whole point is, if I've stolen your database as the attacker, I'll start trying every single password I know against your system, like trillions per second, trillions. And Bcrypt slows me down from doing that dramatically. What used to take an hour to crack your password, now it takes a month or more. Like, I'll get to it, but it takes me a long time and a lot of resources to get there. The second go-to algorithm is Scrypt. So this includes a time delay and a memory cost. Like, I can force Scrypt to use 32 megs of RAM every run to limit parallelization. This affects performance, but if I steal your database and I am analyzing your password, I can usually use a rig of GPUs and have 1,000 processors going at you at once. If I have a bigger memory cost, I can only do so many based on my GPU card and similar. If I'm using Argon 2i, the winner in the latest password storage competition from cryptographers, it will limit the time. You can limit the cost. You can increase the time cost, increase the memory usage, and only allow one thread at a time to compute on your ciphertext. So this is how you do it right. In fact, Argon 2i is now native in PHP. These algorithms are available in most languages. So again, we saw this, how well adaptive storage algorithms delay the attacker from password discovery. And Bcrypt's everywhere. We got Bcrypt in Java, we got Bcrypt in PHP, we got Bcrypt in .NET as a separate NuGet. It's everywhere. And if I'm an attacker and I've stolen your database and I have my own custom hardware, FPGAs or ASICs, you really want to use Scrypt above 32 megs of RAM for each run. This affects performance. So before you roll this out to your community, like any other big software change, you should do load balancing to make sure that you have the right performance metrics you're expecting before you roll this out. I had a customer being really progressive. They used Bcrypt with a work factor of 15. It shut their login system down for performance. So make good choices here. I recommend Bcrypt 13. That's a good minimal value for work factor today. Last, if you have a good key storage mechanism in place, as a final step, encrypt the Bcrypt hash or the Argon hash. And this is if you already have key management and secrets management, you can already do good key management. Go ahead and encrypt or HMAC as a final round. And by the way, good key management means that you're not leaking the key to user code. Usually use an HSM or a separate secrets management service. Feed the password data into the hardware, run it through an HMAC or encryption, and spit out the ciphertext. By doing this, the key never is touched by developer code. We just use a service to do cryptography for us. This is a concept called key isolation, fundamental when it comes to security. And as we wind down here, coming to an end, I recommend you take a look at this presentation from Alex Muffet. Alex Muffet is the most entertaining security pro on Twitter. He's a Facebook security architect with no personal filter, and I'm a fan of that. I don't like personal filters. So he's a barrel of monkeys. So go back to 2014, Google this talk, and it shows you really in detail why all these best practices we talked about, they're used by Facebook and why they're so important. This is really an amazing presentation looking under the hood of what's happening. So let's review this. When a user registers with your system, when it gives you a new password, we want to store that well. We start by running SHA-512 on the user submitted password. We first make sure it fits our policy first. Then we hash it. Then we run it through Bcrypt with a 13 minimum for the work factor. And then that adaptive hash out of Bcrypt, we encrypt it with our key management solution and put that in our database. This is really rigorous password storage that you should consider for sensitive apps. When I'm trying to log in, we do this. I'm trying to log in. Well, here's my submitted password. Let's hash it. Let's go. Let's then encrypt it with that key secrets management. Let's encrypt it. Now we have an encrypted version of the hash of the password. Then we take that adaptive hash and use the Bcrypt compare function to see if it matches what's in the database. And if we get a match, let them log in. That's the secret here, folks. As we wind down here, a few notes. Passwords are definitely an attractive target in data breaches. SQL injection is just the beginning of how we can lose passwords. Legacy password storage mechanisms almost never handle these modern attacks. And so please take this stuff seriously. And you got to use the Bcrypt, Scrypt, or Argon 2. Those are the only good ways to store a password. Everything else is really pretty poor for a variety of reasons. I mean, with respect. And if this is a legacy system with a lot of risk, a lot of like sensitive data and financial processing and similar, I'd prioritize this pretty quickly. This is a tempting and common target against your applications. And if you have these kind of problems and you don't have multi-factor, ooh, that's, again, I put that in a sound the alarm. Let's make some big choices to change that quickly. Additional topics are about legacy upgrading and security question storage and how to handle a breach. These are further topics we'll talk about in the master class when I teach for GOTO. So that's the end of our presentation here. I'll give you one more for fun. Here's a bonus round. You ready? Don't hard code your passwords. If I go into GitHub or your code repository and I see a root database password, that's a really bad idea. We want to move these days to a secrets management or secrets vault like HashiCorp Vault or the Amazon Key Service. Some kind of vault to store your application secret is key. And last, please be careful of backdoors. This is a backdoor I snuck into a system as part of a legal job. I got hired as a secret boss. They didn't know I was a security pro. They onboarded me like I was a developer. And I was able to get this check, and they're like, "Oh, we do security review here." And I had this checked in and pushed live within 48 hours, and showed the CEO how I backdoored his whole company and got admin access on all his web properties with one check-in that no one looked at. Oh yeah, and the check-in was done over Slack, and people look at Slack. So I did the check-in, and my check-in showed up in Slack. Then I went right to that Slack channel and just kept typing and saying things, so my check-in disappeared. And so it wasn't that big, and it's a multi-billion-dollar company. In 2 days, I own your whole system, and nobody saw me check it in. This is common, so be careful of this stuff as well. What do we do today? We talked about modern password policy. We looked at the importance of why password storage matters. We looked at hashing and other adaptive storage algorithm solutions, and we did a few other things along the way. That's it for me. If you have questions for me beyond today, I am jim@manico.com. Always happy to take questions. I'm even happy to take a few right now. So does anybody have any questions about anything we talked about today?
You can use the chat or just unmute yourself and ask.
Yeah, sure. Regarding, well, this has been about user passwords. I believe most of these things could be translated, well, yeah, to APIs, passwords in key and basic authentication. Do you have any special advice for that?
Yeah, I mean API keys. You're talking about like some service gives you an API key, you add it to a URL and hit that API and get full access to everything. That's horrible. Don't use API keys. API keys are horrifically bad security, and I would not use them in a high security environment, because this is one string that gives me auto authentication, auto access control with no it's leaked everywhere. It's in the URL. URLs leak like a sieve all over the stack. Refer headers in your browser. They leak over logs and web server logs. So you put this API key in a URL, it leaks everywhere, and I get my hands on it easily. I would not recommend API keys. I use API keys for things like doing detection. You know, I'm gonna give you. Hang on here. We're gonna go deep. This is a really good question, and it's triggering me to want to answer you in depth. So give me a sec here. I'm gonna dig up a slide for you. I'll find it. I'll find it fast. So I'm gonna go into this is my master slide list here. I'm gonna go into my web service security talk. That's what I'm looking for here. Web service and microservice security. Oh yeah. And I want to talk about from here API keys and show you this slide. Yeah, there we go. Can you see this? Can you see this slide now?
No.
How about now?
Yeah, better.
So API key is made to limit how much someone can use a certain API, like for throttle limits or quota. For example, if I want to embed Google Maps on my web page, then I need to get an API key from Google and link that API key to my domain only, and now I can embed that on my web page. So if it's for pay-per-use, so the stakes are low, then API keys are okay. But I want you to understand, API keys are useless for authentication, and they're useless for access control. It's a shared key. They get leaked often. Revocation can be really challenging. If we're using an API key in the back end only, between your web server and a back end, it's less of a problem. But if it's like user-driven API keys, you just leak that to me and I got access to that. It's really dangerous. So I don't recommend API keys. I recommend you do more of this. If you want to do machine-to-machine communication, then use mutual TLS. If you want a machine to act on behalf of a user when they're not logged in, that's delegation for OAuth 2. If you're doing like real microservices, use a JSON Web Token or OpenID Connect. Use the right tech for the right need. And API keys are almost never good for security. And I caution against them. But if you do use them and want to store them effectively, then use a key management solution or a secrets management solution like HashiCorp Vault. They're made for database passwords, API keys, and similar secrets that the application developer needs to store in the app. So there's a long answer to a short question. Is that helpful?
Yes, a lot. Thank you.
Any other questions? Love questions. So this is how I teach. When I teach live, I'll drink a lot of coffee and try to keep upbeat. I drink coffee all morning and a Diet Coke all night. And so I try to keep upbeat. So hope to see you in the class. And but if you're not going to be in the class, if you have questions, email me anytime. I'm easy to find. I'm jim@manico.com. Hit me up anytime. Always happy to answer your questions on secure software.
Thank you.
Thank you so much, Jim. That was awesome.
Awesome.
I'm so glad I hope it's helpful to your world.
Yeah, very helpful.
And by the way, I want to use a new term. People use the term social distancing. I hate that term. And I
Me too.
Physical distancing is important.
Physical distancing.
Social closeness using modern technology, but physical distance to keep everybody healthy. I like that way better than this whole social distancing.
Me too. I hate when people say social distancing. I'm like, I'm still being social.
Yeah, exactly.
It's just physical distancing. Thank you. Yes. I don't have to fight this fight alone.
I'm gonna head out now, but I gotta tell you, everyone here is such a great, I could just feel all the positive energy from everyone. It's really a treat for me to be here talking to you. So thank you so much, everyone.
It's a treat for us as well. Thank you so much, Jim. If you want, you can join the Slack channel, and if you have time and anyone has any questions, I posted it in the chat. So just join everyone, join our Slack channel, and yeah, if you have any questions, just ask them.
Excellent. I'm already on GOTO Slack, so hit me up there as well if you like.
Wonderful.
Thank you, Jim.
Thank you so much.
Peace out, everyone.
Tim.
Bye.
Have a wonderful evening or day. Bye.
Bye.